going to be talking about segment and angle properties, and this is the first day of properties. Now, the segment and angle properties that we use for these proofs, a lot of them overlap from the algebraic proofs or properties that we've seen before. But before we actually learn the properties, there's some notation that we have to be very careful of using, okay? So the first one says, what is the difference between angle A and M angle A? Well, most of us know that little m means measurement. So this notation means the measurement of the angle. And angle A is just your name of the angle. And the symbol that we're allowed to use with measurements is the equality symbol, and you'll be able to see that a little bit later. And the symbol that we're allowed to use with the names is the congruency symbol. Okay? Same thing with segments. The AB without the bar above it is the measurement of a segment. And the AB with a bar above it is just the name of the segment. And just like the angles, the measurement, we're only allowed to use the equal symbol, and the names, we're only allowed to use the congruency symbol. And you're going to be able to see that in a second. Okay, so let's talk about the properties. We are allowed to use the addition, subtraction, multiplication, and division properties, but all of these are of equality, so we're only allowed to use these properties when dealing with measurements of angles and segments. So I'm going to show you some different examples of these. So let's say we have the measurement of angle 1 minus the measurement of angle 2 equals the measurement of angle 3 minus the measurement of angle 2. And to simplify this, we actually can add the measurement of angle 2 on both sides, and when we add on both sides, that's our addition property of equality, just like in the algebraic proofs. Our next one, let's say we have something like AB plus BC equals BC plus CD. We actually can subtract the BC's on both sides, and that is our subtraction property of equality. Now, the multiplication property of equality, we always use that when we're trying to get rid of a fraction. So let's say we have 1/2 times the measurement of angle A equals 10. We can get rid of this fraction by multiplying by 2 on both sides. And the very last one is the division property of equality. Let's say we have something like 5 times AB equals 10. To get the AB by itself, we can still divide by 5, and that is our division property of equality. These are really easy to recognize. You've seen them before. They're almost exactly like the ones in the algebraic proofs. The next ones are the symmetric, transitive, and substitution properties. We have seen these before, and we also can use them for the angle and segment proofs. Okay, so the symmetric property of equality or congruence, you could do either of them. I'm going to show you both of them. When we have a symmetric property, we can flip. We can flip our statement. So the symmetric property of equality, let's say we have the measurement of angle 1 equals the measurement of angle 2. We can use the symmetric property by flipping this. So our new statement is going to be the measurement of angle 2 equals the measurement of angle 1. And we can also use this with a congruency statement. Let's say we have the line segment AB is congruent to line segment BC. We can flip this statement and say BC is congruent to AB. So we can use it with a congruency statement as well. Same with transitive. Transitive, we can use it with equality or congruence. And remember, with transitive, we can cross out what's in common and write a new statement. So let's say we have AB is equal to BC, and BC is equal to CD. Well, what we have in common here is the BC. We can cancel those out, and our new statement is AB equals CD. We can also do this with a congruency statement. Let's say angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. We can cancel out the 2's, and our new statement is angle 1 is congruent to angle 3. So that's our transitive property of equality or congruence. Now this last one on here is the substitution property of equality, and this is only used for of equality, and this is where we plug something in for something else. So what if we have AB plus BC equals 10, and then I say that BC is equal to 5? Well, I can plug in or substitute BC for 5, and I can rewrite my statement as AB plus 5 equals 10, and that's substitution. So we're substituting in the 5 for the BC. Okay. Now I have two brand new properties. They're the same property, but we can use it for angles or segments, and that's the definition of angle congruence and the definition of segment congruence. And it's very important that we get our equality and congruency statements correct. So this property allows us to move from congruency to equality and equality to congruency. So it's really important that we can use this. So here's an example. Say we start with angle 1 is congruent to angle 2. This property allows us to rewrite this statement as the measure of angle 1 is equal to the measure of angle 2. And we actually can go the other way. Let's say we start with a measure of angle A is equal to the measure of angle B. Using this property, we can rewrite that statement as angle A is congruent to angle B. So it can go either way. But this property allows us to go from congruency to equality to equality to congruency. And it helps us finish our proofs and to use different types of properties. Same thing with segments. We can say that line segment AB is congruent to line segment BC. And using this property, I can rewrite this statement saying that AB is equal to BC. And we can go the other way around. We can start with AB equals BC, and we can rewrite it as saying AB is congruent to BC. Okay, so that one's a really important one. We see it a lot. It's brand new to us, so we like to practice this, okay? So let's practice these properties. And this is just like the ones that we did in our algebraic properties. So we're going to see what's going on from statement 1 to statement 2, and our reason is going to be our property. So if we look at the first one, angle 1 is congruent to angle 2, and then angle 2 is congruent to angle 1. Well, those flipped. So flipping is symmetric. And if we notice, we both have congruency symbols. So this is the symmetric property of congruence. You have to be really careful in identifying the symbols because this is the symmetric property of congruence because we're using congruency symbols. So always double check that. Now the second one is angle A is congruent to angle B, and then the measurement of A is equal to the measurement of angle B. Since we're moving to congruency to equality, this is our special property, which is the definition of angle congruence, which allows us to move between those two symbols. Our next one is PQ plus ST equals RS plus ST, and our new statement is PQ equals RS. If you notice, the ST is being subtracted on both sides, so this is our subtraction property of equality. Next up, we have 2 times the measure of angle A equals 30 degrees, and the measure of angle A equals 15 degrees. So what we've done here is we divided by 2 on both sides. So this is the division property of equality. And the very last one is BC equals CD and CD equals EF. If you notice, these two CDs are being canceled to get BC equals EF, so this is our transitive property of equality. All right, let's look at some more examples. This first one, BC equals AD, and then we have line segment BC is congruent to line segment AD. Since we are switching from equality to congruency, that's our brand new property, which is the definition of segment, since we're dealing with segments, congruence. That special one that allows us to move from equality to congruence and congruency to equality. Now our next one says LK plus JM equals 12, and then LK equals 2, and our new statement is 2 plus JM equals 12. Well, we're substituting in the 2 for LK, so this is our substitution property of equality. Next up, I have 20 degrees equals the measure of angle A, and then the next one, measure of angle A equals 20 degrees. This one is being flipped, and we're dealing with equality symbols, so this is our symmetric property of equality. Next up, I have measure of angle A minus 20 degrees equals 65 degrees, and then I get measure of angle A equals 85 degrees. So if you notice, we're adding 20 degrees on both sides, so this is our addition property of equality. And our very last one, I have line segment KL is congruent to line segment MN, and then line segment MN is congruent to line segment RW, and our new statement is line segment KL is congruent to line segment RW. We notice that both of these are being eliminated, so that's our transitive property of congruence. We have congruency symbol, so this is of congruence. So that's our transitive property of congruence.